record on this computer. Welcome everyone, it's good to see you again. Today we're going to continue solving a couple problems of two-dimensional motions, right? And tomorrow I'm going to continue to solving another couple, all right? In the first situation, remember that for two-dimensional motion, that most of the time we have to think about the equations provided in the horizontal motion in a vertical motion. And sometimes it's so useful to create a free body diagram or a picture representing what the problem says. Well, we have two problems. In the first problem mentioned, a student stands at the edge of a cliff in trouble stone horizontally over the edge with a speed of 18 meters per second. According to the problem, the cliff is 50 meters above a flat horizontal beach, as shown in figure. All right, you're going to see you have the cliff, the student located over here. He's thrown the stone with initial velocity of 18 meters per second and from a height of 50 meters. Okay, and we have a few questions. The first of all, what are the coordinates of the initial position of the stone? The coordinate of the initial position, my dear students, in simple merely words, will be what will be the height and the distance that the stone that's supposed to move. Well, actually, the y coordinate is the height. We got that already, 50 meters. And we have to find out what will be the distance. That will be the x coordinate. Well, this is going to be the first question. The second question is, what are the components of the initial velocity? I mean, what are the values of the velocity in x and the velocity of y? The letter C asking for how long after being released does the stone strike the beach below the cliff? So they're asking for how much time the stone will hit the ground, just like in the when it reaches the red arrow located in the ground, actually. And the letter D, they're asking for what the speed and angle of impact does the stone land. Simplemente words the magnitude and direction of the velocity. This is what the problem mentions in these situations. Okay, what we have to do? Well, in physics, my new student, we have several questions, but no necessarily we have to solve the problems in that specific order. We can answer the questions. A volunteer, for example, we can respond the letter C after the letter A, after the letter B. It doesn't matter. But in the end, you have to respond all of the answers. Okay. Remember, we have the picture of the problem, and the first thing that we have to do before to start any problems is determine what will be the known variables and the unknown variables. All right. So at the beginning of the situation of the problem, the data. What values do we have? Okay, first of all, we have the initial velocity, the horizontal initial velocity that will be 18 meters per second. Another situation, the angle theta. This is just like a curiosity because the problem never mentioned with what angle the student throws the stone, right? But if you read the problem at the beginning, the problem mentioned the student throws the stone horizontally. Horizontally. What does that mean? If you remember the concepts that we learned the last year in the principles of the line, when we calculate the slope of the line or the inclination of the line when it's moving in horizontal path, that will be at 0 degrees because we're talking about an horizontal line. For that reason, the angle of inclination in this situation will be 0 degrees because this student throws horizontally, the stone horizontally. And the slope of the line, horizontal line, that will be 0 degrees. That's why this value will be 0. And after that, we have a height. Okay, what will be the value from height? The value from height, even though we have a positive 50 meters, that will be negative 50 meters. And you're going to ask, Why negative? Because this stone is falling down. So for that reason, they're asking for the distance, height. They're asking for the period of time that accompanies the velocity, velocity x, velocity y, and at the same time, the magnitude, direction of the velocity. All right, just to explain you already, it won't be necessary, it don't be necessary to respond to the questions at the same order of the every the same order that the problem requires. For that reason, if I really want to find out what will be the position and velocity, will be necessary to find out the time. Okay, and we have these three values. Why is so useful these three values? Because if you really want to know what will be the period of time, I got the first formula. I will be equal negative 1/2 gravity times square plus initial velocity sine of theta multiplied by the period of time. We have this first equation. We know the initial velocity, we know the value of gravity, we know the value from height, we know the value of angle. So we can actually substitute them and so forth the time. However, if you see the second part of the problem mentions sine of theta, and if you use your calculator and you apply sine of 0, that will be equal 0. For that reason, initial velocity times 0 times time, the half of this formula can be canceled because all of them going to give us 0. So what we're going to do, we're going to replace the value from height will be negative 50 meters. Remember, because the stone is falling down, okay? That will be given by negative 1/2. Gravity is 9.8 meters per second square, t at the second power. You know, negative 1/2 times 9.8, that will be negative 4.9. Multiplying passes to divide. For that reason, we're going to get negative 15 meters divided by negative 4.9 meters per second square. That will be equal the square root of the value of time. Remember, negative 1/2 times 9.8 going to give us negative 4.9 meters per second square. And because this is multiplying, passes to divide, and because we're looking for the period of time, we don't need to find out what will be the value of t squared. We are looking for what will be the value from t. For that reason, we are taking the square root of this equation and we can divide 50 divided by 4.9. That will be give us 10.20 so on. Taking, sorry, 15 divided by 4.9 and taking the square of this answer, that will give us 3.2 seconds, rounding one decimal numbers. 3.2 seconds, that will be the period of time. Well, if we analyze the problem, well, we answer already the letter C. The question letter C, because the question letter C, they're asking for how long after being released the stone does the stone strike the beach below the cliff. Okay, we got already 3.2 seconds. And because we know what will be the period of time, we can respond the letter A. What are the coordinates of the initial position of the stone? The coordinates means, in simple merely words, what were the distance and height of the stone. Okay, so if you really want to know what was the distance, you know to remember the formula from distance. Distance equals bi cosine theta multiplied by the period of time. Okay, remember the velocity, the stone velocity moves to the right side. For that reason, the velocity will be positive. All right, we got 18 meters per second. And check this out. Cosine 0 won't be 0. If you use your calculator and you apply cosine 0, that will be 1. Why? There is a one singular reason that we're going to study in trigonometry that we call the unit circle. But you're going to learn that the main reason why is a unit circle when you're going to be in 11th grade. You have to learn a few lessons later just to prove why the cosine 0 is 1. But meanwhile, push the button cosine 0, and push the button equal, and the answer will be 1. So we don't need to write the number 1 over here. And the period of time, as soon as you can see, will be 3.2 seconds. For that reason, that distance gave us in that situation will be 18 times 3.2 will be 57.6 meters. 57.6 meters. That will be the distance. And the height, because that you don't need to calculate the height because gave us already. But remember, because the stone is falling down, the height will be negative. For that reason, will be negative 15 meters. Okay? This is going to be the answer of the letter B, the letter A. They're asking for what are the coordinates of the initial position of the stone. Simple merely words. We are looking for distance and height. And why is negative? Because the stone is falling down. All right. Now, because we know the letter A and the letter C, now we can find out what will be the answer of the letter B. What the letter B says. What are the components of the initial velocity? I mean, they're asking for what will be the velocity in x-axis and the velocity in the y-axis. And if you check your formulas, I gave us the last class, the velocity x will be given by bi cosine of theta. This is the formula for the velocity x. So velocity x equals bi, because moving to the right side, will be 18 meters per second cosine 0, cosine 0, that will be 1. For the reason 1 times cosine 0, 18 times cosine 0, that will be 1. So 18 times 1, that will be 18. Now, if you really want to know what will be the vertical position, remember velocity y, that will be equal initial velocity sine of theta negative gravity times time. That will be the equation of the velocity y. And once again, because the angle is 0 degrees, sine of 0, this case will be 0. 0 times initial velocity, there will be 0 also. So the half part of this formula can be canceled, okay? For that reason, the velocity y will be given by negative gt. Remember negative g, that means the gravity. So negative 9.8 meters per second squared multiplied by the period of time, that will be 3.2 seconds. For that reason, the y velocity gave us to negative 9.8 multiplied by 3.2. The answer will be negative 31.36. 31.36 meters per second. And I have a question for you, a quick question for you. Why, okay? The vertical velocity, I mean, the velocity y gave us a negative result. Why? Apart, obviously, with the formula. Would you like to tell me an explanation why we have a negative answer? Why? Why we have a negative answer? And why I'm pretty sure this is going to be the right answer, the velocity y. Any idea?
Mister, I think it's because it's going down.
Exactly. You say the
Because it's
word, man.
falling.
That's because it's falling down. Excellent. That will be the answer. Remember what I explained you already. Anytime in any object, it doesn't matter what kind of object we're talking about, drops, it's falling down, the height and the velocity, that's supposed to be negative. And if you see, we have a negative height over here. And at the moment, we are going to apply the formula, the vertical velocity y or the final velocity in y-axis gave us negative because it's falling down. Excellent. That's why the answer. And mathematical, if we apply the mathematical principles, gave us a negative result. Okay. So we are answer for letter A. We have the answer for the letter B. We have the answer for the letter C and the letter D. They're asking for, okay, what will be the speed and angle of impact of the stone will land? Okay, in that situation, my dear students, we have to looking for the magnitude and direction of the velocity. Because this velocity I'm going to looking for, this is not going to be a horizontal velocity or vertical velocity. This is going to be just like a slant velocity because there has some kind of inclination and simple merely words. What we have to do? Simple. Remember to find out the magnitude of the velocity and you check your formulas. You're going to see velocity that will be equal velocity x second power y velocity at the second power. This is how we're going to calculate the magnitude of the velocity. For that reason, b equals square root of what? Parenthesis, x velocity 18 meters per second elevated at the second power plus open parentheses negative 31.36 meters per second close parentheses elevated at the second power. At the moment, we're going to calculate the square root of this number. Please, my dear students, don't forget to include the parentheses in even though we have a negative quantity, because if we
Yes,
are
sir.
not including, sorry, hold on. If we are not including a negative a parenthesis when we have a negative number, we're going to have a wrong answer. Yes?
Why is the angle 0?
Because if you read a problem at the beginning says, student lands and edges the cliff and throws a stone horizontally. So in the line principles, we learned just the last year, and when we study how to calculate the slope of the line, equation of the line, the slope of any horizontal line that will have an inclination of 0, what? 0 degrees. That's why every time that we drove any object in the horizontal position, the angle of inclination will be 0. That's why. Got it?
Yes.
All right then. So remember, first of all, please solve the operation inside the parentheses. I don't know if you can see the calculator. Okay, let me see. ¿Pueden verla? Sí, ¿verdad? 18 square plus parentheses negative 31.36 close parenthesis second power. All right. Equal button, we're going to have these entire numbers. Now push the button of the square root, push the button answer, and equal. And if you see, the answer will be 36.16. So the magnitude will be 36.16 meters per second. This is going to be the magnitude of the velocity. I mean the speed. They're going to have an impact, but we are missing the angle. And remember, to obtain the angle theta, that will be equal the arctangent velocity y over velocity x. If you're going to check me, your formulas. So for that reason, we can say, all right, arctangent of velocity y, that will be equals negative 31.36. You don't need to write the units meter per second because at the end, those units will be canceled. And velocity x, that will be 18 only, right? And we have a negative angle. A negative angle, that means we're going to count the revolutions clockwise. That means a positive angle. A negative angle, that means when we're counting a principles counterclockwise. But don't worry about it. The result will be the same. If you want to calculate the arctangent, remember, make sure your calculator must be set off in degrees with the letter D. Okay? Push the chip button and tangent. you're going to see tan -1. That means our tangent. Open parentheses and copy the fraction. Negative 31.36, okay? Push the button ABC. You're going to see over, right? 18. Close parentheses and equal button. And you're going to be negative 16.15. Negative 16.15 degrees. And that's it. This is going to be the magnitude and direction, the speed and the angle of impact. Understood? By the way, this is going to be the letter D. All this, the purple marker will be the letter D. Questions?
Understood, mister.
Understood?
Yes,
Mister,
mister.
All right.
Mister.
Uh-huh.
So the magnitude is the angle in which it's at.
No. The magnitude, I mean the value from the velocity. This is the magnitude. I'm going to write over here. Magnitude. Magnitude. And the angle will be direction. Magnitude and direction. So with what speed? That means magnitude. An angle means direction. That means. Got it?
Yeah.
Okay. In a couple classes later, we're going to learn how to calculate the vectors. The will be easier for us because in that situation, it's a mechanical process. The adding is vectors with their two methods, arithmetic speaking. One of them is the graphical technique. By the way, you really need to have at the region of your hand the ruler, right? And how to say the protector, just like this one. Because if you don't have a protector, that's going to be impossible. You can add in vectors. I'm going to show you in a few classes later how to remarkable the angles. Because in the graphical technique, the only thing that we have to do is draw a line with some kind of measure and measure the angles, measure the line, and at the end, we have to obtain the displacement that will be the measure between one vector to another one. But this is going to be a few classes later. Remember what will be the materials? You really need to know to have the ruler and the protractor. There are two kinds. One of them is a 180 degrees, and there's another one 360 degrees, like a entire circle. Okay. Well, that will be on the, if God wills. Today is Monday. On Wednesday, and Wednesday, if God will, we're going to see vectors. You're going to see the addition of vectors is the easier topic of physics. All right. So
Yes, mister.
then let's going to take a look in the problem number 2. In the problem number 2, like your student says, a fireman a distance of 50 meters away from the burning building directs a stream of water from a ground level fire hose at an angle of 30 degrees with the horizontal, as shown in figure. This is the fireman. We have that this is the stream of water. This is a kind of initial velocity, the angle theta, and the separation that will be the distance and the height of the building. Okay, so continue with the problem. The problem says, if the speed of the stream as it leaves the hose is 40 meters per second, the question is, at what height will be the stream of water strike the building? All right, so they're asking for what will be the value from this height. Okay, so what we have to do in this problem? The first thing that we have to do always in every physics problem, my dear students, is identify what will be the known variables. For example, we know the distance, obviously. Distance D, 50 meters. Also, we know the angle theta because the problem gave us this angle theta will be 30 degrees. And after that, we know that initial velocity BO or BI is the same. I have a question for you. This 40 meters per second will be positive or negative? Positive or negative, this velocity of the water? Because it's so crucial to determine the sign. Excuse me?
Positive.
Negative.
Well, no, will be positive because if you see the direction of the hose, it's upward, right? And this the water that's supposed to strike the this burning building. Shh, this is burning up. But that reason the velocity will be positive because the position of the hose is upward. That will be 40 meters per second. What we are looking for, what will be the value from height. All right. So what is the big deal? If you really want to looking for the value from height, the chosen one formula could be this one, right? H equals the 81 half gravity times square plus initial velocity sine theta period time. That will be useful. But what is the issue that we got in this situation? We don't know what will be the period time. If we know the time, we can find out what will be the height. But meanwhile, because we don't know the value from period time, we cannot find out the value from the height. So the first thing that we have to do in this situation is looking for the period of time. For that reason, if you remember, this is the two-dimensional motion. In the time, this is not a vector, it's a scalar. What is the difference between the scalar and vector? Both can be get the measure, but the scalar it doesn't care the direction. That means time is time. It doesn't. Nobody wants it. Nobody says it's upward, downward, left, right. That's why at the moment when to calculate the period of time in physics, there is no negative time because the period time is a scalar. There is no direction. For that reason, if you're looking for how many seconds they're going to move a distance of 50 meters, will be the same period of time that the string of water will strike the burning building. For that reason, we can calculate the time. We got this formula. Distance equals BI or BO cosine theta multiplied by time. Okay? Because we're looking for time, distance divided by BI cosine theta will be the value from t. Okay? What is the value from distance? 50 meters over initial velocity 40 meters per second, cosine 30 degrees equals time. How we can perform this operation, all right? Because this is division, we have to divide 15 minus, divided by that situation. But at the moment, we're going to divide this quantity. We're going to copy 15 divided by open parenthesis because there's a product between them. That's why it's useful. The parenthesis 40 cosine 30 degrees and close the parenthesis. I don't know if you can see that one. Once again, 15 divided by parenthesis 40 cosine 30 degrees and push the equal button. And the answer will be 1.44 seconds. So the period time will be, well, I'm going to locate it over here. Period time will be equal 1.44 seconds. Why seconds? Because we can perfectly cancel meters with meters and the remaining unit will be S, that means seconds. And now because we know what is the period of time, now we can perfectly try to find out what will be the value from height. Do you remember the beginning? I told you already the chosen one will be -1/2 gravity times square plus initial velocity sine of theta multiplying by time. We know the value of gravity? Of course we know. We know the value of the initial velocity? Of course we know. The angle? Of course. The period of time? Of course we know. The only thing that we have to do is plug in the formula and that's it. If we are doing well this process, because the string of the water is moving over, the velocity that will be positive. For that reason, the height of the building that's supposed to be positive or negative. Positive or negative. Uh-huh. Say something. The height of the building gave that's supposed to give us positive or negative. Come on, say something.
Positive.
Positive because it's moving upward. If it gave us a negative result, we have a wrong answer. We have made a mistake in something part of this problem. Okay, so what we're going to do? You know, negative 100 times 9.8, you know that will be negative 4.9 meters per second square, multiplying by the period time will be 1.44 seconds, second power, plus, remember, the initial velocity will be positive because the stream of water moves upward. 40 meters per second, sine of 30, multiplying by, I'm going to put t over here because we have a missing space. I don't know, all on physics, forget about it. I'm moving from here. Okay, height, fail.
Mister, can you move the camera?
Just hold on. Mhm. Mm, Better? Mejor ahí? Okay. All right then. So once again, height equals negative 1/2 times gravity. You know that will be negative 4.9 meters per second square because 9.8 times negative 1/2 gave us this answer. Period time, 1.44 seconds at second power plus initial velocity 40 meters per second is positive because the string of water moves over sine of 30 degrees. In this equation, multiplying by 1.44 seconds. You can do it in two parts or at once. My strong recommendation, do it by parts. You don't need to give it an exact advanced answer. Just do it by parts, right? For meanwhile, in the first part of the problem, we have parentheses, negative 4.9, close parenthesis, open parenthesis, 1.44, second power. So the first part of the answer will be negative 10.16 meters in the first part, plus second part, 40 sine 30 gave us 20 times 1.44. The answer will be 28.8. 28.8 meters. So the value from height, that will be negative 10.16. The answer will be 18.64 meters. And that's it. That's going to be the solution set of the problem number 2. Questions?
No, mister.
Okay. Let me know when you finish to copy that one. Que yo creo que no nos va a quedar tiempo. ¿Qué horas? Ya creo que no nos queda chance para este ejercicio. Yo creo que mañana lo vamos a continuar. Porque en lo que tarde en copiarlo, después volverlo a hacer y no nos va a quedar tiempo. Creo que con estos 2 ejercicios lo vamos a dejar hasta aquí. A no ser que tengan preguntas. Si tienen preguntas, adelante. Es tiempo de hacerlas. Con confianza. ¿Pueden leer bien lo que está en la pizarra? ¿No hay ningún problema? Bueno, voy a asumir que no hay problemas.
Si puede bajar un poquito la pizarra, mister.
No, la pizarra no la puedo bajar porque está
La
empotrada.
cámara, perdón, la cámara.
¿Cómo bajarla? Ah, para abajo, así. O así. Es que si lo bajo así, ya estuvo, ya no llega más. O quiere que la acerque, la aleje, ¿cómo?
Así está bien, mister, así está bien.
Ok. Es que esta pizarra está empotrada. Entonces no la puedo. No se preocupe, siempre al final de la clase le voy a tomar una captura de pantalla y se la voy a mandar al grupo por cualquier cosa. Entonces mañana vamos a hacer otros dos. Y así pasado mañana comenzamos con vectores. Pero recuerden muchachos, tengan a la mano regla y el transportador, así como este. Puede ser de 180 grados o el de 360 que es la pelota entera, el círculo completo. Bueno, entonces si no hay preguntas y terminaron de copiar, pues tengan buen provecho. Dios los bendiga y los veo si Dios los permite el día de mañana. Si Dios lo permite, muchachos, no sé si ustedes sabían, pero tengo entendido que ya a partir del segundo parcial ya estarían viniendo al colegio. No sé si ya les había mencionado algo o no. Ok, bueno, you're
¿Cuándo, mister?
dismissed. Que les decía que si Dios lo permite, ya en el segundo parcial ya estarían asistiendo al colegio, les estoy diciendo. Sería más o menos, porque el parcial termina, si mi memoria no me falla, creo que como el 18 o el 22 de octubre. Significa que así más o menos a ojo de buen cubero, yo creo que ustedes estarían viniendo la primera semana de noviembre. Más o menos ya estarían asistiendo al colegio, segundo
No,
parcial. Ahora, lo que sí sé es de que lo máximo que pueden estar en el aula son 15 alumnos. Creo yo que, por ejemplo, el lunes, por decirlo así, ¿verdad? Un lunes iría a los primeros 15 y los otros se quedarían en casa. El martes alternarían y así sucesivamente. Eso es lo que tengo entendido. Pero cualquier información adicional que tenga, yo se lo voy a hacer saber. ¿De acuerdo? Bueno, entonces, muchachos, Dios los bendiga, los guarde, los cuiden. Tengan buen provecho. Los veo mañana. Podéis ir en paz.
Dios.
Adiós,
Bueno,
mister.
Adiós,
cuídense.
mister.
Le voy a tomar una foto a este y se lo puedo mandar en el grupo, no se preocupen.